the last program, we developed the sine law for oblique triangles. Side A divided by the sine of angle A equals B over sine B equals C over sine C. This law can be applied when we know two sides and an angle opposite one of the sides. Or any two angles and one side. Well, here's a triangle that needs a bit of work before the sine law can be applied. Unfortunately, there are two unknowns in any equation we try to solve. But angle A is easily found by subtraction. 78 degrees. We now have an equation with only one unknown. A calculator gives the values of sine 78 and sine 63. So the left side is 51.1. Solving for B gives 45.5. Using the same procedure, side C is easily solved. C is 32.1. So the sine law can be used effectively when we know two sides and the angle opposite one of them, or two angles and one side. Let's look at this triangle. We're given two sides and the included angle, but we have a problem. When we put these values into the sine law equation, we're stuck. Any combination we try, we have two unknowns. If, instead of angle C, we know side C, the problem remains. There are still two unknowns. So, for side, 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 and side, angle, side, we need a new law, the cosine law. Triangle ABC is an oblique triangle. Let's drop a perpendicular from A to BC. Side A is now divided. If we call the right segment X, then the left must be A minus X. We'll name the split point D and the length of the perpendicular H. Let's establish some relationships between the sides and angles. In right triangle ADC, X divided by B is the cosine of angle C. Multiplying both sides by B, X equals B cos C. We'll store this equation for the moment. Also, the Pythagorean theorem gives us B squared equals X squared plus H squared. We'll want this shortly too. Now let's look at the other right triangle, ABD. Applying Pythagoras in this triangle, C squared equals A minus X squared plus H squared. We can now condense these three relationships into a single law. Expanding A minus X squared, we get A squared minus 2AX plus X squared. One of the expressions we saved was B squared equals X squared plus H squared. and we can see x squared plus h squared in the equation. Let's substitute b squared for x squared plus h squared. The other expression we saved was x equals b cos c. We have an x in this equation, so let's substitute b cos c. Rearranging the order of the terms gives the most common expression for the cosine law. Probe 1 is about to discover that they need the cosine law to continue their journey. Ed and Charlie must calculate their distance to the center of the galaxy, but they need some help first.
Charon, checkpoint. This is probe 1.
Go ahead, probe 1.
We need positional data of Charon and Milky Way center for our distance calculations.
Roger, probe 1. We have you at 2 kiloparsecs from Charon, and we observe an angle of 99 degrees between probe 1 and Milky Way center. Confirm also that Charon checkpoint is 9 kiloparsecs from Milky Way center.
Thanks, Charon.
The boys must solve this oblique triangle and thereby calculate their distance to the center of the galaxy. Labeling the triangle A, B, and C, we see that side A equals 9 kiloparsecs, side B equals 2 kiloparsecs, and angle C 99 degrees, a side-angle-side situation. Earlier we saw that this type of problem could not be solved with the sine law. Let's apply the cosine law. Putting these values into the equation, the only unknown is side C. We can now solve the equation directly. Probe 1 must travel 9.5 kiloparsecs to reach the center of the galaxy. As we saw before, the sine law also fails with a side-side-side situation. The cosine law will work, though, because the cosine of angle C is our only unknown. Solving gives us angle C, but how can we find the other two angles? Well, knowing angle C as well as side C, we can now apply the sine law. The only unknown in this equation is angle B, and it works out to be 57.1 degrees. And so angle A must be 44.4 degrees. We now have two laws that allow us to work with any oblique triangle. If given side-side angle, or angle-side angle, use the sine law. For side angle side, or side-side-side, the cosine law. However, just try one or the other and see what works.
Well, Ed, have you picked up these two laws?
Yes, Charlie. Of cosine, of course.